Hello, in this video I'm going to show you guys how to build a polynomial function when you're given intercepts. Okay, so first of all, this is tied in to something that you have on your Q&A for basics of polynomial functions right here, where we have our four equivalent statements. And the focus now is on the last of these statements. If x minus r is a factor, x is and then r is a real number, what this is basically saying is that r is a root or a zero if x minus r is a factor. So by the way, the reason that we use r for this is because it stands for root, and a root can sometimes be considered synonymous with a zero. A real root is just like a real zero, and so on. But so we're going to use those as solutions also, so a root is a solution to the equation. But if x minus r is a factor, then r is a root or zero. So in this case, if we're given a situation where we're asked to form a third-degree polynomial function with zeros -2 having a multiplicity of 1 and 1 having a multiplicity of 2, then we would say since -2 is a 0, it follows that x minus -2 is a factor. Okay, and the same thing with 1. If 1 is a 0 or root, if 1 is a 0, then it follows that x minus 1 is a factor. And since that x minus 1 has a multiplicity of 2, it's a factor that appears twice, like that. Okay, so what we're going to do is we're going to write this first in factored form, because we're almost there. So we have f of x, and I'm going to throw this a in here, which I'll explain in a minute, is equal to the product of x plus 2 times x minus 1 squared. Now this is going to give us a polynomial that has -2 as the x-intercept that appears once, because there's an exponent of 1, has a 1 as the x-intercept that is touching the x-axis because it appears twice. The a, for now let's just assume a is 1, keep it simple, okay, but this is factored form. In the next example you're going to see why a is important. Alright, polynomial form, because we're asked to find this in both factored form and polynomial form. Polynomial form means we have to multiply it all out. Okay, so let's go ahead and multiply this out. So I'm going to start out by multiplying the x minus 1 times itself. So x minus 1 times x minus 1, I get x squared minus 1x on the inside, 1x on the outside, that's minus 2x, and then plus 1. And I'm going to multiply that by x plus 2. So far I've just expanded this out to these three terms. Now I'm going to multiply this 2 terms by these 3 terms. Essentially I'm distributing twice. So first I'm going to distribute the x here, here, and here to the 1. So I get x times x squared, which is x to the third, and x times -2x, which is minus 2x squared, and plus x times 1, so plus x, and then now I'm going to distribute the 2 here, here, and here. So 2 times x squared is plus 2x squared, 2 times -2x is minus 4x, and 2 times 1 is 2. And this is all times a, and now we're just going to combine like terms here, and so we have nothing to go with the x cubed. And these two cancel each other out. That doesn't always happen, but it happens this time. These two combine to give minus 3x, and then we have the plus 2. And this is going to be f of x, and if we let a equal 1, then that's our polynomial form. That's it. Okay, and that's just based on the information that we were given. Now in the next example, we're going to see a little bit more about what that a is all about. Okay, so let's look. This time we're given a lot more information. We have a longer fourth-degree polynomial function. We have 3 zeros, and one of them is supposed to have a multiplicity of 2, so just give this 2 a multiplicity of 2. But we also know this time the y-intercept is 32. So let's use this information to write our polynomial first in factored form, and then we're going to see how we can use this and why we need that a. So we're going to write f of x equals a. The first factor is x minus negative 4. Remember, it's x minus the 0, or x minus the root, so x minus negative 4. And that has a multiplicity of 1. X minus negative 1. That also has a multiplicity of 1. And then x minus 2 with a multiplicity of 2. So there's our function. Let's just simplify this a little bit. So we have f of x equals a times x plus 4, x plus 1, x minus 2 squared. All right, there's our polynomial in factored form. But now we also know that the y-intercept is 32. In other words, f of 0 is 32. So if I replace all of my, here I have f of 0 is 32. Meaning that if I replace all of my x's with 0, my f of x should be 32. So I'm going to make this 32, and this would be a times 0 plus 4 times 0 plus 1 times 0 minus 2 squared. And let's solve that for a. So we have 32 equals a times 4 times 1 is 4 times 4 is 16. So a is 2. Now I can write my factored form without the variable a. Here, without the variable a. So in factored form, f of x equals 2 times x plus 4 times x plus 1 times x minus 2 squared. And again, that's factored form. Now we get the fun of multiplying this together. And this is really just an exercise in how well you can multiply without making mistakes. So just try to be really careful with these. So first I'm going to do the x minus 2 squared. So x minus 2 squared looks like that. And that's x squared minus 4x plus 4. Now I want to multiply that by this product. This product is x squared plus 5x, right? 4x plus 1x, so 5x plus 4. So I have, I'm just going to write down both of them here. X plus 4 times x plus 1 is x squared plus 5x plus 4. Now, this is 3 times 3. If I multiply this times this, which is what I have there, because I have to multiply this all out, right? If I multiply these together, it's going to give me 9 terms. And I'm going to make one of those little boxes. You might have seen this before, where I have 9 squares. This is going to be kind of like a multiplication table. On one side, I'm going to put, or on the side, I'm going to put the first one, so it doesn't really matter which one goes where. So x squared minus 4x plus 4. I don't know what the mark where that came from, but x squared plus 5x plus 4 up here. All positives. And now I just multiply like I make a multiplication table. So here and here, that gives me x to the 4th. Here and here, that's 5x to the 3rd. Here and here, that's 4x squared. Here and here, that's negative 4x to the 3rd. Here and here, negative 20x squared. Here and here, this box would be minus 16x. Here and here would be plus 4x squared. Here and here would be plus 20x. And then the last one would be just a 16. Now let's look at our like terms. There's only one. You can kind of look diagonally this way, and it helps you with combining the like terms. So there's only 1x to the 4th. There is a combining like terms here is 1, 5 minus 4 is 1, so 1x to the 3rd, so plus x to the 3rd. This way there's 3 terms that have an x squared, so they're like terms. So I have 4 plus 4 is 8, minus 20 is negative 12. Here's like terms again with just the x's, and there's plus 4, and then a plus 4x, and then a plus 16. And that's all times 2. So, whoops, one more step. One more step is to distribute the 2, and I've got everything in polynomial form. So f of x is 2x to the 4th plus 2x to the 3rd minus 24x squared plus 8x plus 32. Polynomial. Okay, one more, same kind of problem. It's just that this time we're going to get the information from a graph instead of from paper. This looks like a third degree, but let's see what happens. So we have one x-intercept is at -1/2. Another one is at 3, and that one has a multiplicity of 2. So if the zeros are at -1/2 and 3, and the one at 3 has a multiplicity of 2, then we can go ahead and write x minus -1/2 or x plus 1/2 times x minus 3 squared. There's an a in front of it, just like what we did before, and that's our function. But we have a y-intercept again, so we're going to get. Okay, so looking at the graph, we can see that there's a y-intercept at 0, 9. So that means when x equals 0, f of x equals 9. So we know, let's write that down here, f of 0 equals 9. So we can put 9 equals a, that's a 9, that's an a, times, these are x's are 0 now, so that would be 0 plus 1/2 times 0 minus 3 squared. Let's see, we get 9 equals 9 over 2a. 9 over 2a. So what happens with that? We multiply both sides by 2 and divide by 9, and we get a equals 2. Okay, so now that we know a equals 2, we can rewrite this in factored form. So our factored form would be f of x is equal to 2 times x plus 1/2 times x minus 3 squared. Okay, now that's factored form, and it's done in factored form. Now we can just expand this to polynomial form. Okay, so multiplying this out, I'm just going to multiply it out and then we can compare answers. Okay, and then this is the factored form multiplied out. I first squared the x minus 3 right there, and then I distributed the 2 over this to get 2x plus 1, right? 2 times x is 2x, 2 times 1/2 is 1. Then I multiplied this 2 by these 3, I distributed twice, I got 6 terms. There they are. From those 6 terms, I combined like terms, and there's the final answer. Okay, I hope you found this video helpful.